Okay, 2.6 is zeros of polynomials. Remember, we've talked about this several times. Zeros of polynomials are when you set the polynomial equal to 0 and what x equals. We've also talked about that if you have zeros, that's where it crosses the x-axis, or if they're real. And we know that the number of zeros equals the degree of the polynomial. Now, how do we solve that? Well, there are several options. You can factor. We've talked about doing that with synthetic division. Quadratics, of course, we've looked at where you can just look at them and factor or use a quadratic formula, those kind of things. We also talk about completing the square with the quadratics. So the quadratic is kind of a sub case because it's a little bit easier. And then the other way you can do that is on the calculator if it's real. And the calculator can also give you a place to start with the synthetic division. If you know you have a cubic function, for example, and it looks like this. If we know we have a cubic function and that means it has to have 3 zeros because it's a degree of 3, well, we can see that only one of them is real. So if you use your calculator to find this one, then you can plug that into the synthetic division, and then you'll end up with a quadratic that you can solve with the quadratic formula to get the imaginary other two roots, or zeros. So how do we even get started, though? So we can start with the calculator, or we can use the rational root theorem. This is on page 78 of your book. And I'm going to write out kind of the different things to do and just kind of go with it for a second, and then we'll kind of go back and clarify. So to start out, you're going to come up with some numbers. We'll call this one C, which is the factors of the constant term, and D, which is the factors of the leading coefficient. That's the coefficient in front of the highest term. So if it's a degree 4 polynomial, then the leading coefficient is the number in front of the x to the 4th. Then you take these numbers that you just have, and you have C over D, and those are your possible rational roots of the polynomial. If you have complex roots, or if you have irrational roots, like square roots that don't work out evenly, you'll find those after you've got it down to a quadratic, so that you can use the quadratic formula for that part. All right. So these are possibles, and you'll use synthetic division to get what you need from that. All right, so this sounds a little bit confusing, so let me just do an example so that we can see how this works. Let's say we have this function, g of x equals 3x to the 4th minus 7x cubed minus 8x squared minus 2. So if we want to find out what the possible roots are, and remember, the last lecture we talked about, those roots will give us the factors, and then we can continue to factor it all the way down, which will give us all the roots. So they're all related that way. So what we do is we start with our C, and those are all the factors of the constant term. So this is the constant term here. So what are our factors of 2? Well, plus and minus 1 and plus and minus 2, because the only way you can multiply to get 2 is, in this case, negative 2, is 1 times 2, and one of them has to be negative and one of them has to be positive. So those are all our factors for that. And then for D, this is our leading coefficient because this is a degree 4 polynomial. So we've got plus and minus 1 and plus and minus 3. Those are our possibilities. Those are all our factors for that. So what are our possible rational roots? Well, we take C over D. So we're going to have a list of all the possible ones. So we'll have 1 over 1, plus and minus, of course, and then 1 over 3, plus and minus, of course. And then we'll take our 2 and put it over 1. And then take our 2 and put it over the 3. So we take all our C's and put it over all the D's. So these are all your possible rational roots. So what you are going to do when you want to factor that is you'll pick one of them to start with synthetic division and see how you can factor that out and end up with it factored all the way down. So this is how you find the possible rational roots right here. List out all your factors of the constant, list out all your factors of the leading coefficient, and then set up this ratio. You have a whole list of things to test. Now, let's go ahead and factor one using this. So we have f of x equals 2x cubed plus x squared minus 25x plus 12. So what are all our factors for 12? Well, we've got 1 times 12, right? And 2 times 6. I'm just writing it this way so they'll be in numerical order. And then 3 times 4. So those are all our all our factors. So then all our factors of 2 are just 1 and 2. So what does that mean our possible rational roots are? Well, we've got 1 over 1 and 1 over 2. And then we've got 2 over 1 and then 2 over 2, which just gives us 1. We've already written that one down. And you keep going through and putting all these out, and you end up with plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, and then plus or minus 3 halves is the other fraction. So these are all our possibilities. If you take these and put them over, so all of these over 1, and then all of these over 2. So 1 half, 1, 3 halves, 2, 3, 6. So there they are. So we need to test and see. Now, if you're working on these in a group, by all means, each of you pick a different one and test it, because you're not sure which one's going to work, because not all of them will work. What you want is to have synthetic division where you have your remainder of 0. So for example, if we start with 1, we've got, put out our coefficients here. Okay, so the goal is to have a 0 right here. Otherwise it doesn't work, because to factor it, it's got to go in evenly. Remember, we're dividing here. It's got to divide evenly or it's not a factor. So we put our 2 here, multiply, add, multiply. Okay, you can already see this is not going to work. This is going to be negative 22, and we're not going to end up with no remainder in this case. So let's try another one. Like I say, if you're working in a group, test multiple. Each of you test a different one. So we're going to test 3. So we've got 2 here, so that's 6, and that's 7, 21, negative 4, negative 12, 0. That's perfect. This means that x minus 3 is a factor. Remember, we talked about this in the last section, that if this number here, x minus this number, is a factor if this remainder is 0. And here we're left with 2x squared plus 7x minus 4. Now, once you get to this quadratic stage, it's pretty straightforward. You go ahead and factor it like you need to with quadratics, or use the quadratic formula so that you can get it finished. You don't need to use synthetic division once you get down to this stage. Now this actually, we know it's 2x times x, and then you just have to play around to see what we get to make it work. We know we need the signs to be opposite, and in this case it factors because we have 8 minus 1 is positive 7, which is our middle term, so that's what it gets to be. So this factors out to be our x minus 3 times 2x minus 1 times x plus 4. So there's the factor. Now you see what worked. Well, positive 3 worked, and negative 4, because this is x minus negative 4 up here. And then what's this one? Well, this is positive 1/2. So those are the ones that worked. All the rest of them didn't work. That's why it takes a while. Now, remember, if you can factor something, then you can find the zeros. So let's say we've got x cubed plus 5x squared plus 2x minus 12, and we want to find the zeros. So that means when it equals 0. So when we want to solve these, the first thing we need to do is factor them, and the first thing we're going to have to do that is figure out what all our possible rational roots are. So possible rational roots, all our c over d's. Well, our d is just going to be plus and minus 1. So in this case, we're just looking at all the factors of 12, which we just did. So those are all the possible factors of 12. So we're going to start with negative 3 in the interest of time here. Now remember, the goal is to have a 0 as your remainder so that you know that this actually is a 0 for this, because remember, this means x minus negative 3 is a factor of that. So 1, multiply, add, multiply, add, multiply, add, and that works. So that means this is one of the factors. The other one is x squared plus 2x minus 4. So this does not factor, not evenly. So we know that we've got, that x minus negative 3, which is x plus 3, right, times x squared plus 2x minus 4 equals 0. So we know we've got this. So that means that the zeros are going to be negative 3, because that would make this part equal to 0, and then whatever makes this equal to 0. Well, in order to solve that, we need our quadratic formula. So we have opposite b plus or minus the square root of b squared minus 4ac all over 2a. When you calculate that all out, you get 4 squared plus 16, which is 20, and the square root of 20, remember that simplifies down to 2 on the square root of 5. If you don't remember how to simplify square roots, you need to make sure you see me so that we can get that nailed down, because you should know how to do that by now. And then when we simplify this, we end up with negative 1 plus or minus the square root of 5. So those are our other zeros. So here's the zeros, which means if this is the zeros, that means the factors are x minus negative 3 x minus negative 1 plus the square root of 5, and x minus negative 1 minus the square root of 5. So these are the factors. Make sure you pay attention to which is which. Yes, they are related. We go back and forth between them. We use the same techniques to find those things because they all are related, but the zeros are where it crosses the x-axis, where the polynomial is equal to 0. The factors are what the polynomial breaks down to. If you multiply these things, three things together, you're going to end up with the same polynomial again. Now, notice right here, when you use the quadratic formula, you always end up with this plus or minus. That's called a conjugate root. If you have the quadratic formula, you're always going to have some number, we'll call it r, plus or minus the square root of some other number, t, whatever. But you always have this plus or minus in here. So that's two different roots, two different zeros, two different factors. They have to go together. You can't have, in this case we couldn't have had negative 1 plus the square root of 5, but not had negative 1 minus the square root of 5. That doesn't work. You have to have the plus or minus. Now this also means for complex numbers that you always have your complex numbers, you have plus the BI and minus the BI. You've got to have that plus or minus. So both the complex and the irrational roots come in pairs. Okay, make sure that you know that. Polynomials, remember, whatever the degree is, that's how many zeros there are, that's how many roots there are. So you're going to have to find, if it's a degree 3 polynomial, you got to find 3 roots. Some of them may be complex, but you still have to find 3 roots. Now, sometimes, for example, in this case, you can have a root that appears twice. So, for example, this factors to be x plus 2 squared, and no matter what you get x minus 2. And what you do is you say this is a 0 or a root with multiplicity 2. That means it happens twice. Now what this means is, on the graph, it means that at that point it bounces off. See, normal zeros, if they're real, they cross over, and it means that's a multiplicity of 1, or it's an odd multiplicity. But if it has an even multiplicity, it's going to bounce off. Okay, you'll see more about how those work as we work with these. So, make sure you understand how zeros and factors relate to each other and how to use synthetic division to find those things. Make sure you understand the rational root theorem so that you can find those possible rational roots, so that you know where to start when you're looking with your synthetic division for these higher level polynomials. We'll do some more in class, and make sure that you have good notes and questions all ready to go.